Hey guys, it's Mr. Holly. I'm here to introduce a project to you today called the Little Caesars Marketing Contest. You have a prompt on page 97 in your notebook that will give you the information you need. But a brief summary is that you will be designing an ad campaign for Little Caesars. We're pretending that Little Caesars has this pizza that is known as the 8x10 deep dish pizza, okay, 8 inches by 10 inches. Now you need to make a new pizza for them known as the double deep dish pizza. So you are going to make the double deep dish pizza, and you are going to create an ad campaign for them. You're going to make sure that you include the size of your pizza, like what are the dimensions of this pizza. You're also going to include the cost of the pizza. Their 8x10 costs $5. How much would you charge for your double deep dish pizza? And you're also going to include some kind of slogan or like catchy ad. If we were in class, we would judge to see who had the best advertisement, the best ad campaign. So that is how this activity begins. It's just kind of open for you to be creative, and then we will discuss your work in just a moment. Alright guys, so hopefully you have created this ad campaign, and you've gone through, in Canvas there were instructions for this, so maybe you've already completed this, but it says to draw your original pizza, which I've put on graph paper because I think it's easier to see, which is an 8x10 pizza, and then to draw the double deep dish, which in my experience, the majority of double deep dish pizzas that people come up with look like this. This is 16 by 20. So what did they do? They doubled the dimension. They doubled each side. They made sure if it was 8 by 10, let's make 8 16. Let's make 10 20. So they have what we would call scale factor. They have scaled this pizza up by a factor of 2. It is now scaled up by 2. They scaled this side up by 2. They scaled this side up by 2. Now, if we were to cut this pizza out, which I've done, and just kind of start to compare these together, my 8 by 10 compared to my 16 by 20, quickly we will see that this 16 by 20 is not twice as large as the 8 by 10. It is, in fact, more than that, and we could kind of sketch this here and see that this will actually fit twice, and then again it would fit down here, so we could actually fit this pizza into the larger pizza 4 times. So by making each side twice as large, we've actually created an area or that is 4 times as much. So this new 16 by 20 pizza that many of you probably created is now 4 times larger. It is not double, it is a quadruple deep dish. It's 4 times the size. So let's kind of think about that mathematically. Like, why would that happen? Well, we know that area is length times width, right? Well, in this case, area was 8 times 10, which was 80. Now, when we think about the area of this larger rectangle, this area is, we started with the 8 by 10, but then we multiplied 8 times 2, and we multiplied 10 times 2, right? The length here is twice 8, and the width is 2 times 10. So we doubled both the length and the width. So if we think about that, what we did, and remembering multiplication is commutative, so I'm going to kind of move these numbers around a little bit. We did 8 times 10 times 2 times another 2, because we took the length and doubled it, which would have doubled the area, and we took the width and doubled it, which now makes the area 2 times 2 bigger, or 4 times bigger. So now we have 80, the original area, times 4, so a new area of 360. This has 4 times as much pizza because we doubled both of the sides, which means the area became 4 times larger. Now, you have some problems in your notebook on the next page that you're going to look at on page 98, and you're going to complete these 3 problems. I will do the first one with you first to kind of get a good idea of how scale factor works. So on the next page, page 88, if the original thing that we had, so say this was like our original pizza, was 4 units and 3 units, and the scale was 8 and 6, what was the scale factor? So we would look to see how much did we scale this up. Well, this was scaled up by a factor of 2, so it's times 2. But we need to look and see how did this affect the area. The actual area, 4 times 3, is 12. And then the scale drawing area, 6 times 8, is 48. So because this had a scale factor of 2, the actual area became 4 times the size. Or we could say the ratio of scale drawing area to actual area was like 4 to 1. It's 4 times bigger. Look at example 2. I think we need to ask, does the area always go 4 times larger when we double a shape? Or, well, excuse me, when we scale a shape up, does the area always get 4 times larger? Well, in this case, we are not doubling, but we are actually making it smaller. We're going from 6 to 2, so we're multiplying by 1/3, and we're going from 9 to 3, so we're multiplying by 1/3. Now, that means my scale factor is 1/3. My actual area was 9 times 6, or 54. And my scale area was 6. So now let's think about the ratio here. What is the ratio of the scale to the actual? So that is 6 to 54, or 1/9. Think about where that 1/9 comes from. 1/9 is 1/3 times 1/3. Because we multiplied each dimension by 1/3, the area changed by a factor of 1/9. I'm going to let you attempt example 3 on your own. But I hope this has been enlightening to you. It is a skill that at first, a lot of us made mistakes with that pizza. Let me change back to this camera. Obviously at first, a lot of us make some misconceptions. We think, oh, we'll just double both the sides, that's going to make things twice as big. Well, that's not how scale factor works. If we scale up an object, we end up manipulating the area. We're actually scaling both dimensions of that area, so we're actually multiplied by the scale factor 2 times. So times 2 times 2, or in that last problem we just did times 1/3 times 1/3, which makes it a factor of 1/9. So it's a little bit unintuitive. It's not what you might have guessed. So check it out. Make sure you do those problems, and we'll have some more conversations about this moving forward. So, all right. Thank you.